the rate of reaction. Here suppose alpha A is reacting with beta B and producing gamma C plus delta D. You can say minus uh, delta A upon delta T, and here 1 upon alpha is equal to 1 upon beta minus delta B upon delta T, and after this 1 upon gamma delta C upon delta D, here 1 upon delta into delta D upon delta T. This is, friends, equal to the rate of reaction, simply ROR. This term, this one term, this one term, and this one term. This term is called rate of appearance of D. This term is called rate of appearance of C. This term is called rate of disappearance of B. This term is called rate of disappearance of A. So friends, we can say rate of disappearance of A divided by alpha, rate of disappearance of B divided by beta is equal to the rate of appearance of C divided by gamma is equal to rate of appearance of D divided by delta. This is equal to the rate of reaction. Now, dear friends, we can say that rate of reaction, this is equal to rate of disappearance or rate of appearance divided by stoichiometric coefficient. So rate of disappearance or rate of appearance upon stoichiometric coefficient, this is equal to rate of reaction. Now we have to take some examples for better understanding of this rate of reaction. Here friends, we are taking example. Here, decomposition of H2O2 is taking place in a closed container, uh, with the rate of disappearance of H2O2 is equal to 10 m per second. Calculate rate of reaction. Now friends, solution of this question. Here we can say minus delta H2O2 upon delta T is equal to rate of disappearance of H2O2. It is given 10 mole per liter per second, like this. Now, friends, we have to write the stoichiometry. So, stoichiometry number 1, here we can write H2O2 producing H2O plus half O2. Here we can say its coefficient, stoichiometric coefficient is 1. So rate of reaction is equal to 1 upon 1 into rate of disappearance of H2O2. So it is 1 upon 1 into 10 mole per liter per second. Here friends, it is M. It is equal to mole per liter. So this is one of our answer. Now I am changing the stoichiometry. Here 2H2O2 producing 2H2O plus O2. So friends, here we can say rate of reaction is equal to 1 upon 2 because the stoichiometric coefficient is now 2. That's why here we write 1 upon 2. Rate of disappearance of H2O2, so 1 upon 2 into 10 mole per liter per second is equal to 5 mole per liter per second. This is again answer. So we are getting here 2 answers. Now the question arises, which answer is correct? So both the answers are correct. Both the answers are correct. So friends, we can say the rate of reaction depends on the stoichiometry or stoichiometry. Rate of reaction depends on stoichiometry. Since infinite number of stoichiometry is possible, so we can say infinite number of rate of reaction are possible. Now, dear friends, here rate of disappearance or rate of appearance is independent of stoichiometry. For example, here alpha A plus beta B gamma C plus delta D. Rate of disappearance of A, it is equal to minus delta A upon delta T. Rate of disappearance of B, this is minus delta B upon delta T. Rate of appearance of C, it is delta C upon delta T. Rate of appearance of D, it is delta D upon delta T. There is no any use of stoichiometry here. So my friends, but here if we write rate of reaction, then it will be rate of disappearance of A divided by alpha. Rate of disappearance of B divided by beta. Rate of disappearance of C, sorry, rate of appearance of C divided by gamma. Rate of appearance of D divided by delta. So it is very clear that rate of reaction depends on stoichiometry. Now friends, we can say fourth note, without stoichiometry, rate of reaction is useless concept. So we can say without stoichiometry, rate of reaction is useless. There is no any use. Why? Because it is dependent on stoichiometry. But friends, in the exams, sometimes stoichiometry is given and sometimes stoichiometry is not given. Sometimes stoichiometry is given and sometimes stoichiometry is not given. So when stoichiometry is given, then you have to find rate of reaction according to given stoichiometry. But friends, if stoichiometry is not given, only then adopt that stoichiometry which uses a least integers as a stoichiometric coefficients. So least and integers. So you have to, it means if stoichiometry or stoichiometry is not given, then stoichiometric coefficients should be least integers. Now here, suppose that stoichiometry is not given. Suppose stoichiometry is not given in the question paper and rate of disappearance of H2O2 is given 10 mole per second, then which stoichiometry we should adopt? Here H2O2, H2O plus half O2. We can't adopt this stoichiometry because this is fractional. We should adopt the stoichiometry in which the stoichiometric coefficients are least and integers. So 2H2O2, 2H2O plus O2. This is adopted stoichiometry. So we can say rate of reaction is equal to 1 upon 2 into 10 mole per liter per second. So it is 5 mole per liter per second. This is the right answer in the JEE main exam and NEET-UG exam. Thank you very much. Thanks a lot.